Welcome back, my poker-faced pookies. Today, we're going to have another episode of Fun with Foos, and we're going to be covering homework number 3. I feel a little bad. I came into this Davis room, and there were two nice young ladies. They were working on their Spanish homework. So in the background, there might be some awesome conjugation tables that, hey, if you don't want to study econ, the least you can do is brush up on some Espanol. But my focus today, I'm officially your econ teacher, unfortunately. So we're going to be hopping into these problems. Today, I think our edition is about demand. And kind of the core of demand. Let's make sure this is still good. Okay, I think we're good. Wait, it's that one. Okay, so I think the core of demand is basically, we saw how like consumption decisions work between like budget and preferences in the previous units, and now I just want to make it like super generic. So like, what if I don't have a specific bundle that I can plug in the numbers, but like I just want to know generally the trends. We can also find the types of goods. That's going to be important in this unit. And we're going to have some interesting graphs that we've never looked at to kind of piece it all together. So that's just a general overlook. And I think a lot of these problems are fairly similar and involve a lot of the same steps. So we can hop into number 1. So we're given a utility function, and we're literally just asked to find the demand for something. So for all these, we're always going to start with our magical little formula. I recall doing this on number 1 too last time. That the game is pretty much just always MRS equals to MRT. That's the trick. That's the golden rule in ECON410. So to get our MRS cooking, we are going to take the marginal utility of x over the marginal utility of y. And just a forewarning, I will probably get kind of lazy with writing out formal things because we're going to be doing a lot of that today. So that's going to be a 1 plus y, and then the x drops off. This is going to be just x. Nice. And we set that equal to, so our MRT, since we aren't given any prices, and like as I just said, we want to make these things generic, it's just going to be price of x over the price of y. And then we're just going to have a quick little cross multiply. So we're going to get, I'll just expand that out a little, like this 1 plus y. So we're going to get py plus y times py equals px times x. And what I want to do with this guy is the same as every other demand function. You're pretty much always just going to plug it into your income statement. So we have income equals price of x times x plus price of y times y. And something we'll notice right here that's pretty cool is I see that price of x and x match up, but we want to solve for x here. So a little tip and trick here is whichever one you set up for, like whichever one you isolate, will be the opposite of what you get. So I want to isolate for y here, because by isolating for y, it will spit out x, which is what I want my final answer to be. So I will scooch that little guy over. So I'll get pxx minus py is equal to ypy. And from there, we get this awesome ypy, like substitutes easily in. So I'm going to get income equals price of x times x plus price of x times x minus py. And from here, I think it just cleans up pretty easily. So we're going to get I equals 2px x minus py, because this is just the same term. And the last step, I want to isolate for x. So, sorry, we're running out of room. Got to migrate to the top of the page, just like the monarch butterflies. So we have income. We're going to divide. Let's first add that PEMDAS. Wait. Yeah, I think that's right. I always want to add this guy first, but technically that's not the right order of PEMDAS. But I think we know what we're doing from here. It's pretty simple algebra in, and then divide both sides by 2px, and cross that out, and now we have our x. And hopefully that is one of the answers. I plus py over 2px, which is C. Excellent. All right, sorry, we're back. There were people running around outside. I guess they didn't hit their step count. They were going on their late night run, and they were just like kind of peeking in at me through the window. I guess they were window shopping for a new teacher. But I think this problem is going to be the same steps as the last one. So MRS, that's going to be 1/2 x to the negative 1/2. This y will drop off. And we just do the same. We get a nice little parallelism going on. So those cancel. And we're going to be left with y to the 1/2 over x to the 1/2. And that's going to be equal to our price of x over our price in y. So I guess we can, if you wanted to, you could square this whole thing. And maybe I will do that. So we can square, but oh, that is terrible. But if we square both sides, then we should just get y over x equals to price of x squared over price of y squared. And from here, we can do a little cross multiplication. So we get y py squared equals x px squared. And unfortunately, since we have these squares, I don't think we have an awesome trick going on like we did in the last problem. But I can easily I can just divide this over. I'm trying to find x, so we're going to solve for y here. So I'm going to get y is equal to x px squared over py squared. Alrighty, so now we're going to put a little bit of this into a little bit of that income statement up here. So we're going to get I is equal to pxx plus the py times plug that sucker in. Pxx squared over py squared. And this probably looks a little scary, and I'm starting to sweat a little, but I don't think it's that bad. Okay, so the py's are going to cancel. I noticed that we have xpx in two different terms, so I'm going to use a little bit of the distributive property, and I'm going to take pxx, and since that is like its whole term, we just get 1 there, and then plus, if I got rid of an xpx, we're going to have one of the px's, because it gets rid of the squared, and then we had our py from earlier. So it's going to look like that. And this is kind of messy algebra. It looks a little gross for sure. This would be, I'll come clean. I did actually mess up and had to jump cut. But this is my second time running through this algebra section. But from here, I'm trying to isolate x, so we can just divide the 1 plus px over py over, and that's equal to pxx. And for my final coup de grace, I am going to go x is equal to income divided by, and then I'm just going to take that px from over here and divide it over 1 plus px over py. The little peewees. And hopefully, I think that gets us IPX1 plus PX over PY. Awesome, that's B. And let's make sure that is in fact right. Okay, the answer is B. That's sneaky. They put PY and PX mixed up. So if you weren't closely checking, you might pick A by accident. On this one, I had this problem relies around the central understanding of what complements are, and it took me a second to process it. But I'll start with this equation that S is equal to 3C. So if you recall the little flip-flop method that we learned last time, whenever you see a coefficient in a perfect complement or a perfect substitute problem, you probably want to flippity-flop. And what this means is if I put in 1 coffee here, then I would want to have 3 sugars. So like 3 times 1 cup of coffee is in fact 3 sugars. So this is the equation that you were set up with, and it would make sense because coffee also gives you more utility, which is why it has a higher coefficient. But I at first was like, why is it not 3S equals C? And if you do it like that, then you will have a terrible answer. But from here, we'll notice that we already have like our S and C. We don't even need to go any further with like MRS equals to MRT type stuff. So I know that if I just plug it into the income, then I will get the price of S times, and then S was 3C, and I know that P of C times C. So I think this is literally all we need, because then we'll isolate for C and everything will be super fine and dandy. So, although I do need to process how we're going to factor this, I'm going to take I, and I can definitely factor out a C from both of these terms. So I see C and I see C. I carbon copy people on emails. Now, I do have a C, so let's factor that out, and we'll get 3PS plus PC. And this is just a little one-liner, so income divided by 3PS plus PC is equal to C. Oh, we gotta close that guy up. Close the fence. If you're gonna open the fence, you gotta close the fence. And is this an answer? C is equal to I over 3PS plus PC is the answer. In fact, A, it is. Let's go, baby. I forgot my normal piece of paper, so I've been having to improvise with the phone method. Normally I write down all the answers to make sure I'm not a doofus beforehand, but I forgot, and I just had to put them in my notes app. So this one is very similar to a poll that we did in class that hopefully you remember. But if you don't, the steps are the exact same. We're just MRS equals to MRT. It's it's the same stuff every time. So we're going to get 2x, that's our MUX. MUY is just going to be 1, which is equal to price of x over price of y. For reference, when something is divided by 1, that's just the same thing it already is. So we get 2 over x is equal to the price of x over the price of y. And we get a cross multiplication cooking. So our 2py is equal to xpx. Great. And when I plug that back in, I'll notice that we had this little shortcut that if something is already in terms of xpx, then that makes my life really easy. I can just plug in straight. I didn't even know this shortcut. Normally I always just isolate the variable and then plug in just for the variable. But in looking at your homework, I've been teaching myself. So this is a little annoying though, that I'm looking for PYs. Oh wait, what must be true at a corner solution? I'm looking at the answer choices and we got a mixture of them. So I'll go down this rabbit hole and see where it takes me. So if I want to, okay, if we're at an interior solution, then that means that we are purchasing some amount of X and Y. So I'll just solve for Y, I guess, where I can do I equals PY times 2 plus Y. I just took a deeper look into this problem. We are on the right track. So we are going to take we're going to do I over PY and then subtract out our 2, and that's going to be equal to Y. And ultimately, like, an interior solution means that this is greater than 0. And we also solved for X up here, so X was equal to 2PY over PX. And this is also greater than 0. So interestingly about this X is we know it will always be positive because the price of Y and price of X are also always going to be positive. But this one might not always be positive because if this -2 was greater than the I over PY, then we would have a negative answer. And that would not fly for our interior solution that we're trying to find. So I know that this inequality is the important one that we are going to plug in. So I'm going to just get that I over PY minus 2 is equal to 0. And then we can scoot that over to the other side. So we get I over PY is greater than 2. And so it's asking us in terms of PY. So I'll try to get it in their terms. So I is greater than 2PY, and then divide both sides by 2. So I divided by 2 is greater than PY. So if I were to rewrite this, I want my little alligator going away from the PY. I normally, I was taught is the alligator always wants to eat the bigger one. So you can draw him with little teeth and he's trying to eat the bigger guy. But the bigger guy here is I divided by 2. And this lines up with PY is less than I over 2. So we are locking in A on number 4, which is good. It's good. P5, question number 5, blah, 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 blah. Okay, this is assuming an interior solution, so no corner solution, funny business. And I think this is just asking us to find derivatives, which is kind of a pain. I'll write out which derivatives would be useful. So for substitutes, I'm always looking at the thing with respect to the other price. For inferior goods, I'm going to be looking at it with respect to income. The angle curve is also going to be related to the income derivative, and good X does not follow the law of demand. So that is going to be dx over dpx, the own price elasticity. So I guess we're just going to get started from the top. I'm going to use arrow math. That might be kind of heathenish to some, but this is a lot of derivatives and I don't really want to think about it. So good X and Y are substitutes. This would mean that I want these to be positive. So if I increase PY here, then the whole thing gets bigger. So that's a positive relationship. And if I increased PX, then the denominator gets bigger, which means that I am subtracting by a smaller number, which means that this gets bigger. Okay, lock in. So I do believe these are in fact substitutes because we had a positive derivative. Good X is an inferior good. So if I increased income, then I would be subtracting by a larger number. So this is an inverse relationship, which I do believe is true. The good Y's angle curve is upward sloping. So if I got that, then the income is going to be bigger, so it's a positive relationship. And just a reminder on the angle curve, this is you plot a good with income. So as my income goes up, my amount of Y also goes up. So I am liking that answer. And good X does not follow the law of demand. Okay, let's unprocess. It does not follow the law of demand, and I'm trying to find which one is false. So as I increase price of X, the X becomes smaller. So they have an inverse relationship, which is what I would want. So I think it does follow the law of demand, and hear me out. Number 5 is D. Okay. This is the fishy one. I'm trying to do the double negative here. I hate, no offense to the micro gods, but this little like double negative false crap it's not flying in my books. So if really what I could say is which of these is true, and then I would cross this out, that it does follow the law of demand because this derivative is inverse. So we are following the law of demand, which would make this false, and that is why I'm choosing this answer. Consider the truthfulness. Okay, if the income consumption curve is vertical, so what we are given here is we are told a graph. So let's start by making some of these graphs. The income consumption curve, you can always just draw like two, or at least how I always do it. You have our two goods, and I'm just going to set it arbitrarily increasing in income. So remember, if we increase our income, that means we have the same MRT, but we like shift outward. Then good Y, and you told me that this is vertical, so it's gonna look something like that. And sorry, that is quite the squiggly vertical line. But then good Y is necessarily a normal good. So what I am finding is that when we increased our income, my Y also increased. That I went from this point to this point, so that is more Y, but my X stayed the same. And I don't know if I really care, because it doesn't ask me about that, but about the X, but it definitely, income went up and Y went up, which is the positive relationship that we're looking for a normal good. So I would say that that's in the clear. And the price consumption curve, I do a similar thing with the PCC, where we got X, we got Y, and I always just draw because they kind of give you an open-ended thing that you could do. I always just do, this is my first one, this is my second one, and I imagine the price of X is always increasing. But you can choose however you'd like to do it, but this is the format of ICCs and PCCs. Is on a PCC, you are always going to shift out. So like one of these is going to have, a changed MRT, and like the other good is going to be at the same intercept. And for ICCs, you're always just going to draw two different income levels and draw it like that. So we are given that the blah, 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 the PCC is upward sloping. So if I wanted it to be upward sloping, then I would have to make it look something like that, where as my price of X increased, so as we go from this one, no, it's the reverse. Okay. It is in fact the reverse. So if I were to draw it like this, sorry, the price of X is going to go down. So from here to here, the price of X went down because I can afford more X. So we know that this price consumption curve is upward sloping. And as my price of X went down, as I went from this guy to this guy, I know that I bought more X and more Y. So the demand curve for good X is necessarily downward sloping. And I think all that means this little phrase, the demand curve for good X, I think that's just referring to the law of demand, which says that as X increases, no, sorry, as the price of X increases or decreases, I would expect the opposite response in X. And that's blanket ECON101 stuff that hopefully is clicking in your brain if we just did like X and price, that typically stuff has a downward sloping relationship due to the law of demand. But I do like this answer. And as such, I'm picking C, baby. This problem looks very similar to number 5, but unfortunately, we aren't given our X and Y like we were above. We used to be lazy, but they have cut off the pipeline. So now I'm going to have to do our normal MRS equals to MRT method, which if you're not already sick of, then you are quite the trooper, because I hate this thing. But we are going to get 1, which is our MUX, over 1/2 y to the negative 1/2. If I simplify that, that's going to be 2y to the 1/2 over 1, which is equal to price X over price Y. I'm going to do a little cross multiplication. So I will get 2py, and I think I'll scoot up here, 2y to the 1/2 py is equal to px. Yippee! And if I divide, so I can get y to the 1/2 is equal to px divided by 2py. And to slam that guy home, we can get y is equal to px squared over 4py squared. Awesome. So now that I got y, we got to remember our next most important step. I want you to be like a little robot. You're going to do MRS equals to MRT, and then you're going to like, I got to plug it into the income. So that's going to be our next step, is income is equal to price of X times X plus price of Y times this piece of garbage. Hopefully it cancels out some, or else I'll be very sad. But it is looking kind of good, so that cancels. And processing. If I were to factor this, I'm seeing a px that's common. But maybe I'll just get rid of this thing first. So I'll do I minus, because this is just a plus minus over here, px squared over 4py, oh brother, is equal to pxx, and x is then going to be equal to I divided by px minus px squared over, wait. Okay, in my head, I just had I had an awesome revelation that this square will cancel because I'm dividing by px. So 4py. And hopefully, if that is blah, 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 x is equal to I over px minus px over 4p. Excellent, okay. So we have our little thingies now, and now it's just derivative time. And hopefully you remember the derivatives from up here, but I will make sure good x follows the law of demand. So we're just doing dx over dpx, the own price, and get a little arrow math going. So if I increased price of x, then this thing becomes smaller, and I'm subtracting by a larger number, which would mean that as I increase price of x, this thing decreases. So it's an inverse relationship, so it does follow the law of demand. So this is good. That is not false. That is a true statement. Goods x and y are unrelated goods. So this is talking about, I guess, substitutes and complements. But this is going to be a very niche scenario, so I bet that this one's going to be false just from like the eyeball test. But I would be searching for dx, dpy, and dy, dpx. Awesome. So if I were to take this guy and I were to, nope, wait, yes, dy, dpx. So if I increased px, then this also increases. And if I well, I guess it doesn't really matter because I've already established that this one's a substitute. I assume this one's also a substitute, or if I changed py, then yeah, we are subtracting by a smaller number. So that is a positive relationship. So these are substitutes. These are not unrelated goods. So that does not check out, and I believe the answer is going to be B. Once again, I think I've probably said this multiple times, but if you wanted to be sure and thorough, you would be a good little student, and you would work out C and D. Since I am a reckless, terrible student, I am going to skip them because I found my false answer, and I also have an answer key that makes me incredibly happy with my decision. But if I were working at the homeworks, I would make sure that I solve for everything, so I have a better idea of what's going on. Okay, this one looks very similar to the one from above, that guy. If the income consumption curve is downward sloping, good y is necessarily an inferior good. So we're talking about the income consumption curve. So we're going to have one of these guys again. And what I would encourage you to do, this one's kind of more of like a theoretical question. It is kind of tough if I didn't know what I was doing. There's a very helpful help sheet, a little resource that you can go find that would make this very obvious. But I'll just throw at you the answer key as to why this is the case. And here, I'll try to make these a little more obvious that we're on the same income level. So there are two different types of downward slopers. You got ones that slope downward like that, and we got ones that slope downward like that. We got like very steep downward slopers and not very steep downward slopers. So when we're looking at good y here, so this is, as my income increased, I actually bought more of y here. So going from this point to this point, I bought more y. But in this case, when I have a higher income, when I went from this point to this point, then I'm going to be at a lower y. So like this y was higher than this y. And sorry, it doesn't really look that way on the graph, but like if I particularly made it like that, I think it's more obvious. So that y goes down. So interestingly, we have a mismatch depending on which type of downward sloper you have. And this is kind of a trick question. It revolves around you having seen the help sheet and know that there are two different types of downward slopers. I think, like conceptually, you could work out this way, but that would be a nugget of info that if this was on exam, I would be very happy that I had previewed that. But that is not correct because we have mismatching signs here. And for the price consumption curve, if that is a horizontal line, so as the price of X changes, so I'm going to decrease the price of X, and this is a horizontal line. There you go. That's what that guy looked like. The demand curve for good X necessarily slopes downward. So in this case, if price X goes down, then I bought more of X. Doink. And if we recall from up here when we were talking about it earlier, that this is just by definition, or wait, let's where was I talking about? Yes, up here, that it will be in fact downward sloping. This is just kind of defining what demand curve for good X sloping downward. That's the law of demand, baby. You've been here before. So I do believe that checks out. The price of X went down, moving to a less steep MRT. The X did increase, so we are looking good. So in this case, for number 8, let's get a little check. But yeah, we are going to get B. That only that one is true. And okay, so for number 9, and I think what's awesome about this homework, they threw you a little bone that you don't have to solve 2 utility functions. 9 and 10 are luckily the same. This just in, newsflash, I was solving for the demand functions here, and you can solve for the demand functions. I think it's good practice. However, I was pointed to the idea that from recitation 4, we got like pretty standard knowledge of what Cobb-Douglas utility functions are. So if I just notice that these two are Cobb-Douglas because they're multiplied together, then I guess I have assumptions that you guys have learned that make the process easier, and I will just use those instead of making a giant page of deriving the demand functions. Once again, you can, and it'll line up. However, I want to save you guys time and sanity. So we know that the law of demand holds that goods are unrelated and both goods are normal goods. So when I'm making a price consumption curve, I need to know as the price of X changes. So let's do our generic decrease in the price of X like we always do. And I want to know what dx dpx is and dy dpx is. So since we know that they follow the law of demand, I know that this is an inverse relationship, that as I increase the price of X, or as I decrease my price of X, I'm going to buy more X. So we're going in this direction, that we're definitely going to buy more X. And then what did it say? The goods are unrelated. So that's going to be equal to 0 because this is the substitute effect. Or not the substitution. Don't take that one. They are not substitutes. Do not conflate the two. Substitution effect and not being substitutes are two different things. But this would mean that as my price of x decreases, the amount of x is going to increase, and my y is going to stay the same, because that's what Dad said. So it is going to be a horizontal line. Let's go. And for the final one, we are correct. And for this final piece, I could have just looked at that and saw the giant C stamped on the on the answer key, but I guess I'm just a little goofball. And for this one, we are going to draw, so we're looking at income consumption curve. Once again, if income consumption curve, I want you to always just draw two different, the slopes are always just like kind of not it. There you go. Okay. So we are increasing our income. So if I increase my income, what is going to happen? So we know that they are, what was it? We know about Cobb Douglas that they are always normal goods. So if my income is to increase, then I would expect this one, and I would expect this one to increase. So this would look like from here to here, I want more x and more y. So it's going to go like that, and then it's going to be an upward sloper, and then we're going to get A. Let's go, baby. And that is A for apple. Or what else could A stand for? Do I have any awesome words? We got acción. Okay, so for this final piece, as per usual, I'll just be handicapping the taking the easy way out by using the key. And okay, so for this stuff, I will just highlight what I would think is interesting. So we are given a utility function, two utility functions actually, and Craig wants his demand functions. So what I would do is first, for this one, I would do MRS is equal to MRT, and then I would plug in to our income equals price of X plus price of Y. I would do a little whatever, you substitute in the thingy, you isolate the thingy, you get the other in terms of, oh, actually, this is a perfect time for a lesson about a demand function. So when we're taking these, interestingly, it is very important that why we substitute in to the budget equation is because I want to make sure that the variables are not defined in terms of each other. So oftentimes we'll get like x equals py, px, and then there'll be a y, like when I cross multiplied, and that's very bad. That's what we're trying to avoid, because that's like telling me, like we have a consumption bundle, the like how much x I buy is determined by how much y I buy. And this is why we plug it into the income, so that our variables, our demand functions, are always just in terms of I, Py, and Px. And if your demand function does not match that criteria, then you've probably done something wrong. But in line with the steps that I just outlined, that is how I would find the demand functions. And it does appear that we did that, and we got demand functions here. The next piece is if I were to choose a corner solution, on which good would I spend all of my income on? It's kind of an interesting one. I'm trying to like vibe it out from the utility function, and I would assume that like at a higher amount, I would only want to buy Y, and at smaller amounts, the X is way better. But I guess it kind of depends. So I think that we do, what is it talking about? If Craig chooses a corner solution. So yeah, this is kind of hitting on a point that we mentioned earlier. that since the price of y and price of x are always going to be positive, I know that x is always going to be positive or 0, whereas y can be negative. So I do know that if we choose a corner solution, that we would be spending all of our income on x. And for this last piece, but that's kind of a tricky question that I don't think I would just default know how to do, but for reference, like that I guess that's a common pattern, and I would I would take note of that when they ask for a corner solution, that you kind of build this inequality, and that will be the giveaway to you. And for this final piece, identify which good Craig considers to be income neutral. Okay, well, I would just figure that out by which one has an I in it. So like when you derive it, the I would drop off because there's no I in here. Wait, processing? No, how do I draw? There you go, that's drawing. So we do not have an I in this equation, which tells me that that's very obviously income neutral, and the other one is normal. So that is how I would solve this one. And something I noticed is that the difference between Craig and Annabelle is that they literally just like swapped the coefficient, and like all the stuff happening on all the stuff is happening on x here, and then all this stuff is happening on y. So I'll give you a sneak peek as to this is like basically the exact same as what we just covered on part A. Like it's just reversed. So like when all the fancy stuff is happening on x, it is now happening on y, and then you just reverse the steps. It's the exact same process, and it's just the reverse answer where, you know, now y is always positive. Just flippy flop your a and b, and you will have a good time with that. That would be a really good tip actually on a test. If you noticed that like they have incredibly similar formats, then I would just kind of cheat my way through it, to be honest. That you probably don't have to solve like the same thing again. And I guess for like this homework is kind of tedious, and I would solve the whole thing and show all your work. But on an exam, that'd be prime territory if I noticed that these two utility functions were very similar. I would bank a bunch of time on that without having to redo this entire problem. Because like the first one's definitely gonna take you like a good chunk of time, but you can do part B very quickly. And in this one, we are given a utility function. Oh brother, I'm not deriving another demand function. And it's funny, they give us a similar example as if we haven't already had 28 examples of this exact same problem. So for this, MRS equals to MRT, plug into the thing, get the thing, isolate. I guess interestingly, I think she plugs it in twice. So I guess something interesting with this problem is you can always re-plug in. So where I defined y up here, like I can re-plug in y and then isolate for x, and that will get me my answer. But I'm assuming that it's just easier since we have this little shortcut, the pxx thing and the pyy thing, that it makes it really easy to just like redo the same plug into the budget equation. So they just plugged into the budget twice here instead of re-isolating based on the result of y, which I think it's short, or it's like smart in retrospect. My default would be to plug back into this equation up here. So I would take whatever I found in this and then I would plug it back into that. to get my x, and I think that it should give you the same thing, but their method is pretty smart if you could tell that's what was conspiring. And for this, we're just looking at derivatives again. So hopefully you're familiar with the derivatives. I think maybe I'll just drive home that for law of demand, like I'm always looking at my own price for whether or not something is income related, normal inferior income, I do with a derivative with respect to I, and complement substitutes or unrelated, this vocabulary would be the opposite price. So if I'm looking at X, then I'm taking the price of Y, or if I'm looking at Y, I'm taking the price of X. And I don't really feel like this stuff is pretty chill, like particularly B and C. I think we have plenty of practice on this homework to take derivatives, arrow math, real derivatives, however you want to do it. I saw that on part D, you could actually interpret it in two different ways. So one of the derivatives came to be 0, and one of the derivatives came out to be positive. So we know that positives are substitutes, and when it's 0, they're unrelated. So I think I tried reading this example, and it kind of makes sense, but it doesn't really make sense to me that, I guess the relationship in the first one would kind of be subtle, and people wouldn't act on it as much, but I guess the price sensitivity of Starbucks consumers could be higher if this real world example does not make any sense to you, and how that would actually function in practice, and you don't really want to think about which interpretation this means. I would not scratch your head for that long. It'll probably explode. It'll come out of your head. And instead, I would probably just lock in, if I were doing this homework, I would just take this one, because to me, when stuff is 0, I am defaulting in this class to ignoring it. But I think if you just justified whichever one you wanted to say, that you'd be good, and I would just justify, I think that they are substitutes because this derivative holds true, and that's cool. I think that this case is not something that I am too familiar with, and I don't think is crucial to your understanding of this content. But with that, I think we are done with the homework. I'm always happy to be done with the homework. And now we can move on to a couple of the, what am I looking at? The help sheets. Oh yeah, baby. So what is this handout for? Deriving demand functions. Oh brother, this is terrible. Oh, okay, this is talking about min functions. So they hit you with the flippy floppy for complements. That's always a good tip for, what is this, just another standard one. I think all this is telling you is MRS equals to MRT, plug it into your budget thingy and hope for the best. This is another one of those where, similarly to this last piece on the homework, or let's go find where we had it, right here, that they seem to do a split plug into the budget, which I guess is more efficient. And aside from that, actually, this would be useful. If I were doing your homework, if I were in this class, I would take note of this, and I'd be whoa, this utility function looks really similar to this utility function. And then I would be like, maybe I can basically copy from the help sheet onto my homework and get a good homework grade. And probably the bigger note there is if you do the homeworks, then I would also bet they're going to be super similar to your exams. So if you copy from a help sheet and you understand how to get onto homework, and then you copy from homework onto exam, I think you'll be swimming in good grades. You'll be like Scrooge McDuck playing in his in his gold coins and his doubloons. But I think that's all this is really driving home is MRS equals to MRT, plug in a budget. There are a couple of flippy flops with complements, etc. If you were ever wondering on these types, the derivatives, then I think this handout, where else do we have derivatives? We had derivatives on PCCs and ICCs, putting that together. We also had derivatives for this question. What was number 7? Number 7 was asking us, just like blatantly like categorizing the goods. This album sheet's kind of just awesome. I think it has elasticity formulas too. I think I'll cover this in the overall review video, but a nice easy way to remember elasticities that I think maybe elasticities will be on the next homework. But I always just remember them as you take, like I have baked into my head, I know which derivatives are important. And to finish it off, you just do times, and then you take the reciprocal of what you had. So you do a little flippy floppy again. So like if I had dx dpx, then I just take the reciprocal of that, bada bing bada boom, and that's just all of your elasticity formulas. And if you just like they just kind of create this like cross pattern in like a cross multiplication that's always easy for me to remember. And I also like this help sheet because it labels your axes. So like if you kind of have no idea what you're doing with angle curves and demand curves and all sorts of stuff, then I think this is a really good baseline to figure that out. It tells you what derivatives you need to create them. It kind of tells you like implicitly what these curves even are. Like this is just mapping a good and its relationship to income, which is exactly that derivative. So I think that this is like top 3 help sheet in my opinion. This help sheet's super awesome, and I would spend a lot of time looking at that. This one, I think it says the same thing as the other one, just looks a little uglier and a little more cluttered to me. There are like too many arrows going on. I feel like I'm like an old person. I need to put on my glasses to really understand. Like it all checks out. It definitely all checks out. And maybe it's interesting that it tells you like positive, negative relationships and how to classify the goods. But to me, kind of those things are a little obvious. So this one would be less helpful for me. But if you're like a very like flowchart-esque person that wants to commit a lot of things to memory, then concept map 2 is more helpful. But I personally would use concept map 1, and it gets you more of a holistic understanding that you can then replicate at any time because you got the foundation cooking. For PCCs and ICCs, this one, I was going to mention this question when we talked about, number 8. So this is the help sheet I was referring to, that if you looked at this guy, and what was this, an income consumption curve? Yeah. So there are 2 types of income consumption curves, and this one has it labeled for you to make it more obvious that, like in this one, at the first point to second point, y went down, whereas from the first point to the second point, y went up, and that's crazy. So I would not commit these to memory. Like, I definitely would not commit how the derivative response changes with respect to these things. Like, to me, how I think about ICCs and PCCs is I always just like shift the price. Typically it's downward just because I like to move like away from the origin, and my income will typically be up, and from there I just piece it together with however it's asking me. If it gives me the shape of what I'm looking for, like if it tells me it's horizontal or vertical, then I can do it from there. If it tells me derivatives, then you can figure out the shape from that. But this is good practice. I would not commit this to memory, but definitely good practice and good like conceptual overview of what they are. And what is this little sucker? Blah 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 blah. Okay, this is exactly telling me the steps of how to plug in with kind of a crazy scary example. And I guess probably the most interesting piece is it will connect the vocabulary. So if you were ever like, what does it mean on these when I'm maybe moving a little too fast? And I was just like, good X follows law of demand, which is this derivative. And you're like, yeah, whatever. I pulled out derivatives from seemingly kind of nowhere that I've seen this content a lot, but this help sheet might be helpful if you need some guidance on the vocabulary and the key terms and connecting that with derivatives. But with that, my voice always seems to be fading out at the end of a Fun with Foos episode. I'm not used to Khan. I don't know how the Khan Academy guy, Sal Khan, I don't know how he does it. I guess his videos are normally only like 10 minutes, and mine are the full hour. I guess being an actual teacher sounds tough too. Like, I don't know how, I'm thinking back to like my middle school and high school professors that they were just yapping for like 90 minutes 4 times a day, and they were just repeating that every day. I don't know how they did it, but anyway, hopefully y'all learned something. That's always the first step. Maybe you had a chuckle or two, but probably only one. 2 chuckles is quite the tall ask. And in homage to the Spanish behind me, hasta la vista, amigos.